What all this is getting to is sort of to acknowledge the fact that data volumes are growing. You know, if you had a terabyte last year, you surely have more than a terabyte this year, and you will surely have many more terabytes next year. Part of this is because we are developing better sensor technology that allows us to create more data. Part of this is that the internet and the cloud in general is exposing your services and applications to an order of magnitude or two more users than you previously could have had access to. And then on the other side of this, the cost of storage, like the hard disk prices are falling like crazy. Today you can get a 1 terabyte hard disk for less than $100. So, you know, we're seeing tons more data coming around sort of in all different kinds of forms. So I like to start this slide with sort of taking a look at Google here. So Google processes 400 million gigabytes of data. That's 400 petabytes of data with MapReduce. And the one thing is, I say this and everyone's like, wow, 400 petabytes, that's a lot of data. But I need to mention that this is per month. And I also need to mention that this was in 2007. And so here as we are here, you know, 2 years later, I no longer work there. I don't know exactly what they do now. They haven't announced this publicly since 2007. But if you just look at these trends, you can imagine sort of where this is going. So how does Google do this? Google was sort of very blessed in some ways to be faced with these problems many, many years ago as some of these trends were just starting to emerge. And they had an army of some of the most talented scientists and engineers thinking about how are we going to scale with the data? You know, what started as indexing the web and making this index available to the world is now spread to sort of all different types of things that they do. So let's look a little bit about you know, cloud commodity storage economics, and sort of, you've noticed I've got an iceberg on the back here, and this will make sense, I promise. So let's look at $1,000, all right? So for $1,000, there's a couple things we can do in a computer. We could store 10 terabytes of data. We can buy 10 of these, you know, $100 1 terabyte disk drives, or we could buy about 32 gigabytes of memory. You'll notice there's a pretty big balance, imbalance here. So what this means is you can put 10 terabytes of data in a machine, but you can only load, you know, 32 gigabytes of that into memory at one time. So what does this start to look like? This starts to look a lot like the icebergs that we're all used to, and we see lots and lots of mass underwater. But this iceberg actually paints a much nicer picture than we're dealing with here, because in this picture, about 10% of that is above water. But when you look at these numbers here, 99.7% of the data, so to speak, is going to be sitting on spinning disks. And to pull that into memory and to sort of do what we normally consider processing and analyzing that data, we can really only touch a very small slice of it at any one given point in time. And this is what Hadoop is really designed to address here. Yeah, question? I expect storage prices to fall at the same rate. You know what I mean? So sure, maybe next year when I give this talk, it'll say for $1,000 we can put 20 terabytes of storage and 64 gigabytes of memory in the machine. I don't see this ratio here fundamentally changing. I mean, there's a tiered storage architecture. You're going to be able to store orders of magnitude more data on spinning disks than you're going to be able to load into memory on the machine to do analysis at a given moment. And this is something that if you want to work with the volumes of data that you're capable of storing, you need to wrap your head around. And you need to change the way you think about storing and computing over data. So this is what it leads into Hadoop. Hadoop is a batch data processing system, and it really starts to leverage the power of commodity hardware for big data and analytics. And there's a couple things that we need to point out here to understand Hadoop. As I said, we work with commodity hardware, utility hardware. It's more scalable than a database. You have relational database systems, and they address a very specific need. They enable you to index your data. They enable you to access that data in a very transactional way. They keep this consistent across sort of multiple users accessing this data simultaneously. And this is really important, but it creates a lot of scalability challenges. You try to scale out horizontally and have many, many machines participate in the process of organizing, storing, managing, and analyzing that data. The methodology for Hadoop was all straight out of Google. We're very lucky that Google decided to publish their papers on the methodology that allowed them to scale with the web, and we're seeing this in use across the industry now. But the one thing that's nice about Hadoop is it's open source. And not only is it open source, it's released under the Apache 2 software license, which is basically public domain. Hadoop enables you to do anything you want with the software with no implications and no constraints on the software that you develop on top of the platform. And then where does Cloudera come into this? We try and package this all together and put this in a format that makes it easy for any enterprise to adopt Hadoop, to start using Hadoop, to integrate Hadoop with your existing systems, and to start really working with data at this scale. So I've mentioned before, Hadoop is really, we're seeing a lot of adoption spreading across, many different industries here. The big web companies you all are really familiar with. Yahoo and Facebook are two of the largest contributors to Hadoop. Big companies like Amazon and AOL are huge users of Hadoop. This is not only a US phenomenon. Baidu, the largest search engine in China, is very high up on the list of the largest deployments for Hadoop. But this is not what I think the interesting part is. I think this gets interesting when you start to look at the regular enterprises that are starting to benefit from the methodology that was really pioneered by Google but spread throughout the web companies. You see sort of the New York Times, a very sort of traditional media company was able to use Hadoop to convert archives upon archives of old microfiche data to PDFs to make this sort of searchable and usable to everyone. Fox Interactive Media uses Hadoop for all different types of analytics. They've got many different analytic engines, and Hadoop sort of provides this sort of lower level fabric that allows them to work together. Autodesk is an engineering drafting company. They help sort of people that are working with designing these huge buildings now. When you look at these massive skyscrapers and you consider the granularity down to every nut and bolt in the building, this is a big data problem. You see companies like D.E. Shaw using this for financial services analysis. You can imagine, I've been yakking about data. I've been saying there's a lot of it. I want to call out some specific sources that are obvious and maybe some that are a little bit less obvious about where this data comes from. One of the most exciting places to me personally is simulations and scientific experiments. We're seeing the biotech industry start to get to the point where we can sequence the human genome now for thousands of dollars. The human genome is 3 gigabytes worth of data, and it doesn't fit into a database table. Like there's no, there's not enough structure to it to do this sort of thing. Wireless sensors now, you can take cheap wireless sensors now and spread them across a large area, and each one of them can generate a large volume of data on their own. And being able to bring that data together, aggregate that data, you think about sort of the impact that RFID has had on supply chain operations. This is huge volumes of data here. You already have a bunch of existing databases. You've got your product catalogs, you've got your sales data, you've got your point of sale transactions, you've got all the stuff that you normally put into databases, but maybe you want to start to combine that data with some of the new data that you're generating. Maybe you want to ask questions that span multiple data sources. Hadoop gives you the ability to dump all of this data into one common repository and ask questions that the answers are buried in each different sort of repository and each different type of data. User data. So web companies, many people in this room I'm sure, you've got your web logs, you've got clicks on your website, you've got pictures, you've got videos, you've got bulletin boards. And the interesting thing that I want to call out about this type of data is it's all completely unstructured. If you tried to define a database table for user-generated content ahead of time, one of the things you're quickly going to find is that users will come up with ways to produce data that has nothing to do with the way that you originally imagined. And you can't fit that gracefully into a database. But Hadoop sort of passes on the question of structure. And it allows you to impose that structure later and to extract from that data what you care about at a later time. And that ability to decide later the questions you want to ask about your data is incredibly empowering once you wrap your head around this. So then there's systems-generated data. So I talked about user-generated content. If you've got 1,000 servers in your IT infrastructure, they can all generate heartbeats. They can tell you how much memory they're using at any one time. They can tell you how much CPU you're using. They can tell you what their utilization is like. I mean, they can tell you all kinds of stuff. And again, if you try to sort of stick this into tables, two things would happen. One, you would very quickly fill up a database as you tried to have 1,000 machines pumping data into it. And then you would decide 2 months later, wow, I really wish I asked them to keep track of this other thing as well. And then trying to fit that in there it's a headache. There's one thing I want you to take away from this is that data comes in all shapes, sizes, schemas, and structures. And Hadoop allows you to combine many sources of data in a common format in a way that enables you to ask questions that leverage all of your enterprise data.